right, in lesson 3.6.2, we're going to talk about basically the same thing we talked about in 361, which is creating those equations. But we're going to do it from tables and graphs. So there's a couple of things that can be a little bit trickier here, and we have to make sure we pay attention to some stuff. So tables and graphs can be represented by equations. Data represented in a table can either be analyzed as a pattern, like the data presented in the previous lesson, or it can be graphed first. The shape of the graph helps identify which type, linear or exponential, and then that data using a linear has a constant slope and graph a straight line, y equals mx plus b. Okay, the y-intercept is the point at which the graph intersects the y-axis. To find the equation of a line, find the slope, then replace x and y in the general equation with x and y from an ordered pair, and solve for b. Or if it crosses the x-axis and the y-axis, sorry, you can just pull a point for the y-intercept that way. We'll look at that in just a second too. Now, let's talk about exponentials though. Okay, exponentials are a little trickier. They're the curves, right? So the couple of things we really want to talk about is your general form being f of x equals a times b to the x power. All right. So in the example we have here, it doesn't appear that we have an a, but really we do. What is it? It's f of x equals 1 times 2 to the x power. 1 being your a, and 2 is your b. All right. So the fact that a is 1, we don't have anything else add or subtract on the end, should tell you that when you plug in 0, you get 1 times 1, which means we should go through 0, 1. And again, here, that is. Okay? So, when you're creating your XY chart, this is probably the easiest way to do it. You have 0, 1, and then you have out at 1, it looks like we're at 2. So 1, 2, and then 2, 4. Right? So you can take and we already had the equation up here. So we could have created that t-chart from the equation, but we can also see those points on the graph that's already done. Okay? Now, if you have the points but don't have the equation, you can use the table over here, use the table that you create to actually figure it out. So I know my initial, right? So that tells me that A is going to be 1. And then here, down below that, I know that we're multiplying by 2, which tells me that my base, my b value, is going to be 2. Okay. The other thing I want to point out is this: when a is greater than 0 and b is greater than 1, you will have a curve that is exponential growth of some sort. Right? It'll be flat on the left side, be flat over here, flat over on that side, and it will be increasing as you go from left to right. Okay. Now let's take a look at a different, another example that's going to change some of that. So in the next one, we have a is still greater than 0 because our a here is 1, right? But our b value is between 0 and 1. We won't deal with any b values that are negative, so you don't have to worry about raising a negative number to a power, at least not for what we're doing right now, not for graphing. But we do have to worry about when it's less than 1. So, for example, a fraction or decimal that's less than 1. And what you notice is the immediate difference here is that this is starting high on the left, and it is decreasing. Right, still above the x-axis, but we're decreasing. Right, you would do this part the exact same way. You create out your t-chart, you find the points, and you figure out what's happening each time. What you would notice this time is you have 0, still 0, 1, right? Which is again, that's your initial value. That's the a value, which is 1. And then the next thing you would notice is, well, if I go this way, I really can't tell what those are, but if I go back, so let's see some other values. So I have 0, which is 1, and then negative 1, it looks like we're at 2. Negative 2, it looks like we're at 4. So since I'm dividing as I go down, the other way to think about division, right, is multiplication of the reciprocal. So if we're dividing by 2, that's the same thing as multiplying by 1/2, which again was our b value. Okay, which means that we can pretty easily figure out these now. Okay, but again, the thing to point out here, this is really trying to show you, a is greater than 0, but b is less than 1. Greater than 0, b is between 0 and 1, means you have a decreasing exponential function. Okay, so let's take one more look at something else real quick. Got a couple more. We'll go through these much quicker, and then we'll do the examples. So on this one, notice we have a negative out front. Okay, what that's going to mean, all that really does is it flips it over. So instead of going up like we did before, instead of doing that, it now opens down, and that's because we got this negative out in front. Okay. And on the last one, if we're between 0 and 1, but we're less than a negative out front, right? It's negative here. Instead of it coming down like it did before, instead of doing that, it's now flipped over. It's what we call a reflection over the x-axis. Okay, which just means it opens down. So what you're going to do is you're going to take all the values and multiply them by -1, which flips them over for your lines. All right, so we're going to pause that video there, and then we'll pick up the examples in the next one.